Welcome to a lesson on graphing linear inequalities in two variables. We'll be following the steps outlined here for graphing the solution set of a linear inequality in two variables. So for example, when we want to graph the inequality y is less than 5 minus 3x, so step 1, we write the inequality as an equality statement, which means write the inequality as an equation. So step 1, we write y equals 5 minus 3x. Step 2, we want to graph a linear equation. This is the boundary region of the solution. But also looking at step 3, we need to determine if the line should be solid or dotted, sometimes called dashed. And this is based upon the original inequality symbol. If the original inequality symbol is less than or greater than, we draw a dotted or dashed line. If the inequality symbol is less than or equal to or greater than or equal to, then we draw a solid line. A dashed line indicates a line is not part of the solution. A solid line indicates that the line is part of the solution. So notice our inequality symbol here is less than, and therefore we will have a dashed or dotted line. And now to graph the line, notice how the equation is in slope-to-intercept form, where b, the vertical intercept, is equal to positive 5, which would be the ordered pair 0, 5, and m, the coefficient of x, is equal to negative 3, so we have a slope of negative 3. But let's write negative 3 as negative 3 over positive 1. So now we'll graph our line, but we'll graph a dotted or dashed line. So we plot the vertical intercept, 0, 5, and now because the slope is negative 3 over positive 1, to find additional points we would go down 3 units and right 1 unit. So down 3, right 1, and we'll do this several times, down 3, right 1, down 3, right 1. Let's go ahead and graph our line, which again is going to be dashed or dotted. For our final step, step 4, we choose a test point and substitute it into the original inequality. If the test point satisfies the inequality, we shade in the direction of the test point. If the test point does not satisfy the inequality, we shade in the opposite direction or opposite side of the test point. The easiest test point to select would be the origin, as long as it's not on the line. So this point here, which would be the ordered pair 0, 0. So using 0, 0, we'll substitute 0 for x and 0 for y into our inequality. So we'd have 0 less than 5 minus 3 times 0. Simplifying, we have 0 less than 5, which is true. So we shade in the direction of the test point, or the same side as the test point, which would be this region here. This region, not including the line, contains all the points that would have ordered pairs that would satisfy the inequality y less than 5 minus 3x. Example 2, we want to graph the inequality 3x minus 2y greater than or equal to 6. So we first write the inequality as an equation. So we have 3x minus 2y equals 6. Notice how here, because the inequality symbol is greater than or equal to, we will have a solid line. To graph our line, let's write this in slope-to-intercept form by solving this equation for y. So we'll subtract 3x on both sides. Simplify. We have negative 2y equals, we can write this as 6 minus 3x or negative 3x plus 6. Let's write this as negative 3x plus 6. Dividing both sides by negative 2, we have the equation y equals positive 3 halves x, and this would be plus negative 3 or just minus 3. So notice here b is equal to negative 3, which means the vertical intercept is the point 0, negative 3, and the slope is equal to positive 3 over positive 2. So we'll go ahead and plot the vertical intercept of 0, negative 3, which is here. Because the slope is positive 3 over positive 2, to find additional points we would go up 3 units and right 2 units. And again, we'll do this several times. Up 3, right 2, up 3, right 2. Remember, we can also think of the slope as negative 3 over negative 2. This still simplifies to positive 3 halves. In this form, though, we can go down 3 units and left 2 units to find additional points. If we wanted to do that here, we would go down 3 and left 2. Notice how this point is still on the line. And again, we're graphing a solid line, which indicates the line is in our solution set this time. And that's because of the equal part of the inequality. And now we'll select a test point to determine whether we shade on this side or this side. Let's use the origin again because it's not on the line. So we'll test the ordered pair 0, 0. Substituting this into the original inequality, we'd have 3 times 0 minus 2 times 0 greater than or equal to 6. Simplifying, notice how this is 0 and this is 0, so we just have 0 is greater than or equal to 6. Well, this is not true or false, and because the test point was on this side of the line, we shade in the opposite direction on the opposite side, which means our solution set this time is on this side of the line. Which means this region here, including the line, contains all the points that would have ordered pairs that would satisfy the given inequality. Let's look at one more example. Step 1, write the inequality as an equation. So we have y equals 2x. Step 2, graph the line and also determine what type of line to graph. So notice how the visual inequality here is greater than or equal to, which means the line is going to be part of the solution, and therefore we draw a solid line. Y equals 2x is in slope-intercept form. If we wanted to, we could write plus 0 to help us recognize that b, the vertical intercept, is 0. So if b equals 0, then the vertical intercept would be the origin, 0, 0. And notice how here we have a slope of 2, which we'll write as 2 over 1 to help us graph. So now we'll go ahead and graph the line. Again, we're making a solid line. So we first plot the vertical intercept, which is the origin here. Because the slope is positive 2 over positive 1, to find additional points, we would go up 2, right 1, up 2, right 1, up 2, right 1. Or if we wanted to, we could write the slope as negative 2 over negative 1, which means we could go down 2 and left 1 also to find additional points. So down 2, left 1, down 2, left 1, down 2, left 1. Again, we set a solid line because the line is in our solution set. Now we want to select a test point to determine which side to shade. In this case, we cannot select the origin though, because notice how the origin is on the line, which is our boundary. So let's select a different point. Let's select this point this time, where the ordered pair would be 2, 0. So using the ordered pair 2, 0, we substitute 2 for x and 0 for y. So we would have 0 greater than or equal to 2 times 2. So we have 0 greater than or equal to 4. This is false or not true. So we shade in the opposite direction or opposite side of our test point. So we selected this test point here, which was not true or false, which means we shade the other side, or in the opposite direction, which should be this side here. This region, including the solid line, contains all the points that have ordered pairs that would satisfy the inequality y greater than or equal to 2x. I hope you found this helpful.